Welcome to this video about blockchain technology. In this video, we will explore what blockchain is, how it works, and its potential applications in various industries. So, let's dive in and discover the power of blockchain. How does blockchain work? Blockchain is a decentralized, distributed ledger technology that allows for secure and transparent data storage and sharing. The blockchain concept was first introduced in 2008 by an unknown individual or group of individuals using the pseudonym Satoshi Nakamoto, who also created the first cryptocurrency, Bitcoin. At its core, blockchain is essentially a database that is stored across a network of computers or nodes. Each node contains a copy of the entire blockchain, which is updated in real time as new data is added. Each block of data is cryptographically secured, creating a chain of blocks that cannot be altered or deleted without consensus from the network. The blockchain concept is based on several key features, including decentralization, transparency, immutability, and consensus. Let's take a closer look at each of these features and how they contribute to the functioning of blockchain. Decentralization. One of the defining characteristics of blockchain is its decentralized nature. Unlike traditional databases, which are typically controlled by a central authority, blockchain is maintained by a network of nodes that work together to verify and validate transactions. This means that there is no single point of failure, and no one entity has control over the data on the blockchain. This decentralized structure makes blockchain more resistant to attacks and tampering, and it allows for greater transparency and trust. Transparency. Because blockchain is a distributed ledger, every node in the network has access to the same information. This creates a high level of transparency, as anyone can view and verify the data on the blockchain. Transactions are also publicly visible, which makes it possible to track the movement of funds or assets across the network. This transparency is important for building trust and ensuring the integrity of the blockchain. Immutability. Once a block is added to the blockchain, it cannot be altered or deleted. This means that the data on the blockchain is immutable, or unchangeable. The only way to modify the data on the blockchain is to create a new block that contains updated information, which is then added to the chain. This immutability is one of the key features that makes blockchain so secure and trustworthy. Consensus. There are several different consensus algorithms used in blockchain, including proof of work, POW, proof of stake, polonium-2 sulfide, and delegated proof of stake, DPoS. These algorithms ensure that the blockchain remains secure and trustworthy, even in the absence of a central authority. Now that we've covered the key features of blockchain, let's dive a bit deeper into how it actually works. When a user initiates a transaction on the blockchain, such as sending cryptocurrency, the transaction details are recorded into a block. A block contains several transactions, and it also includes a header that contains information such as the block's timestamp, a unique identifier, and a reference to the previous block in the chain. Before a block can be added to the blockchain, it must be verified by several nodes on the network. These nodes confirm the validity of the transaction and check that it complies with the rules of the network. This process is known as validation or verification. Once the block is verified, it is added to the blockchain. This process is irreversible, meaning that once the block is added, it cannot be altered or deleted. This makes the blockchain a secure and tamper-proof ledger that can be trusted to store and share sensitive data. To ensure that all nodes on the network have the same version of the blockchain, they must agree on every new block that is added to the chain. This consensus is typically achieved through the potential applications of blockchain. The utility of blockchain is vast and encompasses a wide range of industries and applications. At its core, blockchain is a decentralized, secure, and transparent technology that can be used to store and share data in a way that is immutable and tamper-proof. Use cases. This can help reduce fraud and counterfeiting, improve inventory management, and streamline logistics and transportation. By enabling stakeholders to access a single, trusted source of data, blockchain can help improve the efficiency and resilience of the supply chain. By using blockchain to store and verify identity data, these systems can help improve security, privacy, and user control over personal data. Real estate is another industry that is ripe for disruption by blockchain technology. Real estate transactions are often complex and involve multiple intermediaries, which can lead to inefficiencies, delays, and higher costs. By using blockchain to automate and streamline the real estate transaction process, these issues can be addressed. Blockchain-based real estate platforms can enable buyers, sellers, and intermediaries to record and share data about real estate transactions in a secure and transparent way. This can help reduce the need for intermediaries, such as title companies and real estate agents, and reduce the time and costs associated with real estate transactions. Blockchain can also enable fractional ownership of real estate, allowing for greater accessibility and liquidity in the real estate market. Healthcare is another industry that is ripe for disruption by blockchain technology. Healthcare data is often fragmented, with patient data stored across multiple platforms and systems. This can lead to issues such as data breaches, privacy violations, and inefficiencies in the management of healthcare data. Blockchain-based healthcare platforms can enable patients to control and share their differences from traditional banks. Banks and blockchain are fundamentally different technologies that serve different purposes in the financial industry. While banks have been the traditional way of storing and transferring money, blockchain is a relatively new technology that is disrupting the financial industry by enabling secure, transparent, and decentralized transactions. Centralization versus decentralization. One of the main differences between banks and blockchain is the way they are structured. Banks are centralized institutions that are owned and controlled by a single entity, such as a government or a private corporation. They are responsible for storing and transferring money, managing loans and investments, and providing other financial services. In contrast, blockchain is a decentralized technology that operates on a network of computers spread around the world. There is no single entity that owns or controls the blockchain network. Instead, transactions are verified and recorded by a network of participants, who are incentivized to maintain the network's integrity and security. Trust and security. Another key difference between banks and blockchain is the way they ensure trust and security in financial transactions. Banks rely on a system of trust that is established through their reputation and regulation. Customers trust banks to keep their money safe and secure, and governments regulate banks to ensure they operate within certain rules and standards. Blockchain, on the other hand, uses cryptography and complex algorithms to ensure the security and immutability of transactions. Transactions on the blockchain are verified by a network of computers, and once they are recorded on the blockchain, they cannot be altered or deleted. This makes blockchain transactions more secure and resistant to fraud and cyber attacks. Transparency is another key difference between banks and blockchain. Banks typically operate with a high degree of opacity, with customers often unable to see how their money is being managed or invested. In contrast, blockchain transactions are transparent and visible to all participants in the network. This transparency can help prevent fraud and corruption, and promote accountability and trust. Speed and efficiency. Blockchain transactions are typically faster and more efficient than traditional bank transactions. Banks often require multiple intermediaries to verify and process transactions, which can lead to delays and higher costs. Blockchain, on the other hand, operates on a peer-to-peer network, which means transactions can be processed quickly and at a lower cost. Uses and applications. Banks and blockchain also have different use cases and applications. Banks are generally used for traditional financial services such as storing and transferring money, managing loans and investments, and providing other financial services. Blockchain, on the other hand, has a wide range of applications, including cryptocurrencies, supply chain management, identity verification, real estate transactions, and more. In summary, while banks and blockchain both serve important roles in the financial industry, they are fundamentally different technologies that operate in different ways. Banks are centralized institutions that rely on trust and regulation to ensure the security and integrity of financial transactions, while blockchain is a decentralized technology that uses cryptography and complex algorithms to ensure the security and immutability of transactions. Blockchain has the potential to disrupt traditional financial services by offering faster, more efficient, and more transparent transactions that are resistant to fraud and cyber attacks. Thanks for watching the video. I hope it provided the information you were looking for and that you found the content interesting and useful. Stay updated by subscribing to the channel. Bye.